Algebra 2, Section 2.4, using linear models. Got a couple of examples here, and then we're going to talk about scatter plots. Suppose an airplane descends at a rate of 300 feet per minute from an elevation of 8,000 feet. Write in a graph an equation to model the plane's elevation as a function of the time it has been descending, and interpret the intercept at which the graph intersects the vertical axis. Okay. Well, let's talk about the equation first. If we decide to use y and x, you got to determine what the variables are in this situation. And basically, as time passes, the plane's going to be at a different elevation. So if you think about which one depends on the other, I think it's clear that elevation is dependent on time. At time 0, the elevation is 8,000. At time 1, right, 1 minute later, it's going to be 300 feet down from that. That's at 7,700. Okay. So with that in mind, then we can write y equals negative 300 t plus 8,000 would be in slope-intercept form. And you might use E for elevation or A for altitude. I went with Y, but then T for time is something I like to do. Okay, so input output, right? And you could get some more points off of this, right? You could plug 2, 3, 4, 5 in for T, get some outputs for Y, or you could graph it out of slope-intercept form, and you'd have a y-intercept of 8,000 and then a slope of negative 300. Let's take a look at their graph. Here's that y-intercept of 8,000, and interesting the scale that they chose. You wouldn't want to go by ones here, and you certainly wouldn't want to go by ones here. You're never going to get to 8,000. So they made a wise decision here to go by thousands: 1,000, 2,000, 3,000, 4,000, and then yeah, they graph that line. Now I'm going to guess that maybe a good point that they would have picked would have been this one, and then maybe this one too, because you can plug 10 in for this, and it's really convenient to get negative 3,000. So negative 3,000 plus 8,000 would be 5,000, and here's your 10, 5,000. You could do the same thing with 20, and then you draw a line down. They said interpret the intercept at the vertical axis. Well, that's obviously the starting point, right? The plane was flying at 8,000, and then it started to descend. I think it may be a better question to interpret this one on the horizontal axis. What's that one? Well, that would be the point where it landed. That would be the point where you get to altitude 0. Now, I understand that, we're talking about above sea level and you're landing in Denver. That's something different, okay? But, ground level, let's just say. And that would be the point, 26 or so minutes in that the plane actually did land, if it's landing at a constant rate. Or if it's descending at a constant rate, I want to say. Okay, that's one. Here's a different one. A spring has a length of 8 centimeters when a 20-gram mass is hanging at the bottom end. All right, now stop and think about that. This is an ordered pair, like I tried to say in the last video. When you see information like this, and there's a 2-variable situation, this is an ordered pair. Now stop and think about this. You have a spring that's a certain length, and you have you're hanging weights on that spring and then measuring how much the spring has stretched out. Which one depends on the other? Does the weight of the thing that you hung depend on the length of the spring? Of course not. That sounds ridiculous, right? It's the other way around. When you hang a mass, then the string spreads accordingly. So if we're going to use, and they're using X and Y here, so I'm going to do the same thing. I'm going to use X and Y. We're going to let Y be the length of the spring, and X is going to be the weight, or mass, I guess I should say. Okay? So with that in mind, and knowing that we list ordered pairs X comma Y, this would be 20 comma 8. Right? Each additional gram stretches the spring another 0.15. So what you could do with that is you could add a gram, 1 gram, to 20 and get 21 and use 8.15. Or for that matter, you could add another number. What if you added 10 grams? Then that would be 30, and you'd be adding, what would it be? You'd be adding 10, so another 1.5 would be 9.5. Okay, and you could use really any 2 of the points that I've come up with. I came up with 3. You could come up with more. You could use any 2 of these points to come up with a line. Now you got to think back a chapter. What were we doing to find a line? I would use point slope form, and I would calculate first the slope. Now I'm going to go ahead and I'm going to use this point and this point. And I would calculate the slope, and we're going to go 9.5 minus 8 over 30 minus 20. That's 9.5 minus 8 is 1.5, and 30 minus 20 is 10. And what's that? Oh, that's 0.15. Well, haven't we encountered this number before, right? This actually is the slope because they did tell us each gram, so going by ones is this one. I wanted you to see that in the slope formula, but it does turn out to be that number that we've already encountered, okay? Now what? Well, what would be convenient is this. Since we have a slope and a point, multiple points, we could use point slope form. And I can write y minus 8 is equal to 0.15 x minus 20. Okay, that's in point slope form. Now it says graph the equation. It says write an equation. It does not say write an equation in any particular form. When I show you their answer, they're going to have it in slope-intercept form, but we really weren't directed to do that. Not only that, we absolutely could graph this in its current form, right? Just pick one of these points and plot it, and then use the slope of 0.15, or that would be like going like up 1.5 over 10. So interesting for the scale. Let's see what they did with their graph on scale. I can't remember. Here's what we wrote right here, and then they did change that over to slope-intercept form. I guess it would be easier to graph if you do, so that would be up to you. And then there's the graph that they had. So they went by 5s here and 1s this way, and there's their graph. I guess that looks pretty good. Now I would have given you, if I remember to do it, I'm making this video before I would have given you graph paper, but I'm going to try to give you the quadrant 1 graph paper before you have to do this lesson. Otherwise, I'll have to put it to my Google Classroom, but I think I'll remember to do that. And that works very well with a problem like this in the first quadrant and the previous one that we graphed. Okay, so not regular graph paper, but quadrant 1 graph paper. Here's another question that pairs with the last one. What mass would be needed to stretch the spring to a length of 9.5? Oh, well, that was a coincidence, but we know that because I picked that point right there, 30, 9.5. So the answer is 10. That was a coincidence. I didn't know that was going to happen. So, well, 10 more, or 30 total. But notice what they did. They plugged in 9.5 for the output and solved for the input. And you could have done this with our equation that was in point slope form just as well. Solving for x, they got 30. Okay, now let's look at this next example, and then we're going to jump over to the starboard to plot these points. An art expert visited a gallery and jotted down her guesses to the selling prices of 5 different paintings. Then she checked the actual prices. The data points guess, actual show the results. Okay, so each one of these is like, and they're in, I think in thousands of dollars. So this is like, she thought the painting would have sold for $12,000 and the actual was $11,000. And then she thought another one was $7,000, but the actual one was $8,500, right? $10,000, $12,000, like that, okay? So what I've done is I've gone ahead and plotted those already on the coordinate grid. You should know how to do that already. And would you say that this is trending upward? Would you say there's a trend to this? I hope that everybody would agree that this is a positive correlation, a positive trend. This art expert must know what she's doing, okay? Because if she was just totally guessing, if I went to an art gallery and I started guessing at prices and you plotted my guess versus actual, it'd be all over the place because I haven't any idea, right? So that would be a no correlation situation. But this is definitely trending upward. So as the painting, as her guess was more, so is the painting tending to be more, okay? Now that's called a scatter plot. And then there's something called a trend line. And you should draw a trend line. And I have particular points that I want my line to hit. So I'm gonna cheat a little bit. You can't do this, but I'm gonna cheat a little bit because I want, you're pretending like this didn't happen, okay? That one and that one, okay? because I don't want the slope to be 1. The reason is because I don't want the slope to be 1. So what you're going to do then is you're going to draw a line that seems to model what these points are doing. Okay? Yours could be different from mine. Yours could be different from your neighbors. We could all have a different one, and they would all be acceptable trend lines. Now, there are certainly some wrong trend lines, but as long as you kind of just draw a line that kind of passes through the points, we're going to count that as good. Now, look, what you're not allowed to do, well, I'll come back to that. Notice that my line does not touch any of the points, and it doesn't need to. Some teachers will teach that you want to draw the line so that the same number of points are on one side than the other. Well, if that were the case, then you'd have to have it pass through this point right here, right? But I don't think that's necessary. I think you just draw a line that, by your interpretation, runs right down the middle of the points. Okay. Now, the goal of this, though, is to come up with the line that is that trend line. Come up with the equation for the line. Okay. So I'm going to pick those 2 points that I just kind of pre-chose. So that's 15, 16 and 6, 6. And I can go and calculate a slope. 16 minus 6 over 15 minus 6 is 10 over 9. Right? And then I guess I'll just use the 6, 6 one. Y minus 6 is equal to 10 ninths x minus 6. Just for comparison purposes, this would be fine. If I asked for an equation, I didn't say what form, this would be perfectly acceptable answer to give it to me in point slope form. Just for comparison purposes, because the last thing we're going to do is this on the calculator. Let's go ahead and distribute the 10 ninths. I can do that in my head, but I don't want to make a mistake. (20)3. And then that's it. That should be x here, yeah. And then add 6 to both sides. A really great place to use the math enter function on your calculator that I taught in the last video. So 10 ninths x plus, well, I like the fraction. So, oh no, hold on. Oh yeah, okay, good. So (-2/3). Okay, I like that. So this is an equation that's in slope-intercept form. Now the reason that I did that is because we're going to show you next how to do the line of best fit on the calculator. Now hear that word, line of best fit. All of us can draw a trend line. We all could have an acceptable trend line. They could all be different even, and we could still have a trend line. We might have a bunch of different equations in this step right here. But there is a best trend line, and your calculator can figure it. I don't even know how it does it, but your calculator has a calculation in which it comes up with the best slope and the best y-intercept for this data. I learned it once and I forgot it. Okay. Now, before I get to that, let me just say the one thing you're not allowed to do here, the one thing that would be kind of a cheat, would be that you can't just draw the line back and see where it crosses the y-axis and then just give it to me in slope-intercept form where you're estimating where this is. No, you need to pick 2 points off your line, calculate a slope, and give it to me in point slope form or whatever form I ask for it. Okay, so let's go over to the calculator, and now you're going to learn a little bit about the calculator. If this is too much information, pause it and come back. Okay, I know this video is going to be a little bit longer, but this is the last thing we're doing right here. You see the stat button here? If you press the stat button, it allows you to edit lists. Okay, L1 is a list, L2 is a list, and what I've done is I've entered the X values as the guesses for this art example and the Y values as the actual for this art example. These are the same 5 ordered pairs that the problem gave us. Okay, now look, if I press graph now, nothing happens, and the reason that nothing happens is because we have to tell our calculator to show the points. Okay, this window is good. I think I went from like -5 to 15 in both directions. That's here. Yeah, the window. Let's go by ones here. Okay, But to see the points, what you need to do is go y equals, and you need to turn plot 1 on. To do that, you need to arrow up to it, press enter, and you see now how it's highlighted? See plot 1, and if this is not working for you, you're going to want to bring me your calculator or learn how to reset it. Because if you have a hand-me-down from your sibling, who knows what they've done to your calculator, but I can help you with that too. Most people, this will work. If you have a new calculator, for sure it'll work. You turn on plot 1, and now if you push graph, now you can see the points. Okay? Now, you don't need to see the points to do the next step. I just wanted to show you that that's what they look like. It looks like what we plotted on the first quadrant graph. Now, press stat again and arrow over to calc. And notice all these regs down here. This is lin reg, quad reg, cubic reg, quart reg, and I think below we have an exp reg for exponential. This is linear regression. This is quadratic regression. We'll do that in chapter 5. This is cubic regression and quartic regression. We'll do those in chapter 6. For right now, we want to learn about linear regression. Notice that it's in slope-intercept form. Y equals this, ax plus b is just like saying mx plus b. Okay, so we've selected calc. You can arrow down to the 4 and press enter, or you can just push the 4 button. And most of your calculators are going to show this. If you have an older one, they don't even show this. You do want to make sure that L1 and L2 are here. If they're not, it's the secondary function on the 1 and the 2. You can press second 1, second 2. If your calculator is new, or even if it's not, probably it already says that. And so you just press enter through these, and it calculates. And this is actually the best line, the line of best fit. Now, 10/9, my slope was 10/9. As a decimal is 1.1 repetent, okay? So I was a little off as compared to the best line. Mine was a trend line, kind of my interpretation of it. They have a slope that's a little bit not as steep as what I did, right? Theirs is 1.05, mine was 1.1 repetent. My y-intercept, was negative 2/3. Theirs is like negative 5/100ths, right? So closer to the origin. But again, this is the function lin reg, and this is the line of best fit. Now, there is a way to put that into the y equals. I will show you that on a different day, but you can take all this information and press y equals, and it'll put an equation in there for you. I'm not going to teach that keystroke today, am I? You know what? Might as well. Sorry, one more thing. The keystroke is y equals, let's go to a different color. And then vars, V-A-R-S, that's the button that's on your calculator. And then 5, the number 5, or you can arrow down to 5 and press enter. And then you're going to right arrow twice and press enter. Okay. So on my calculator, if I go, so you've run regression. Now your calculator knows that you ran this. Now you're going to put this into y equals. So you press the y equals button. This is the vars button right here. And then you're going to pick the 5th one. That's statistics, right? So just press 5. And then you're going to arrow over twice to EQ. That's equation. And this first selection is your regression equation, reg EQ, right? So the regression that you just ran, you're telling your calculator, yeah, put it here. Okay, so I'm just going to press enter. So that was right arrow, enter. And it puts that exact equation in there. And now look what happens when I graph it. There's a line that passes right through. This is the line of best fit. Not a good one, the best one. All right, thanks for watching.